My name is Hannah, and for my quality assurance submission, I'll be walking through the complete QA process that I carried out for the Jet Interior Configurator project, including my test setup, QA planning, debugging, documentation, and validation evidence. My assigned role in the project was Quality Assurance Lead, where I was responsible for validating the system's overall performance, ensuring requirements were met, and providing document and test evidence or functionality alongside documentation for team members to follow. At the beginning of the project, I was also working on the business logic area, and I have defined some of the data validation and configuration rules. However, this was later taken over by another developer, and instead of stepping back, I adapted and refocused on my full role on QA ownership and developing, executing, and documenting the test framework that verified system performance across all layers. All development and testing was completed in Visual Studio on my Windows work laptop. This was after having to move over as it was necessary, as the Jet Interior Configurator uses WPF.NET, which only runs on a Windows environment. However, my work laptop has network restrictions, meaning it cannot directly connect to GitHub or external repositories due to company policy. To overcome this, I exported the full Visual Studio solution folder as a zip file after development and testing and transferred it over to my Mac. And on my Mac, I use Visual Studio Code for some version control and file organization. And as you can see, I moved the entire zip onto Visual Studio Code, as you can see here. So my setup was essentially Windows for coding, executing, and testing WPF features, and Mac for GitHub syncing, documentation, and submission preparation. This workflow allowed me to keep everything up to date, even though environments were quite separated. Then my QA process began with a quality assurance plan and a detailed test plan. The QA plan outlined the scope, objectives, and test environments, responsibilities, and acceptance criteria. I followed a layered QA strategy: unit testing to verify vet-specific functionality, integration testing to confirm correct data flow between layers, and regression testing to ensure updates didn't introduce bugs. I also created a detailed test plan to document each test case with the purpose of the test, input data and expected results, actual results and pass-fail status, and evidence of traceability back to the project requirements, and evidence to objective mapping, and a QA sign-off and summary. Once the testing and debugging was completed in Visual Studio, I moved the zip folder over to my Mac and opened it in Visual Studio Code and built a clean QA documentation structure. Here you can see my QA directory, which contains all of my testing, which was facilitated using my Windows computer, including acceptance test, enhancement tests, integration tests, regression tests, system validation tests, and validation and boundary tests, and much more. Alongside these, I created full QA documentation supporting materials, such as a detailed test plan, a QA report notes, a defect log, an evidence mapping, test results summary, all while following Isabel's code styling guide. This structure made the QA environment fully traceable, aligning every test with a requirement for a component in the system. These screenshots show my executed tests within the Visual Studio environment. As you can see in Test Explorer, displaying the different test suites under Test QA. Each of these was run under debug mode with 0 failed assertions. For example, changes persist. Hold on, let me find it. For example, changes persist across save and load simulation, verifying that configuration data saved and loaded correctly. Validation factor. Hold on. For example, changes persist across save and load simulation, verifying that configuration data saved configuration data saved and reloaded correctly. Refactor preserves expected behavior, ensuring that refactored logic returned identical outputs. Save/load performance enhanced after optimization, confirmed that performance improvements didn't compromise behavior. All tests were executed successfully, indicated by the blue check icons of the clean results summary on the right-hand side of the screen. Integration tests verified connections between UI, business logic, and persistence layers, ensuring a smooth data flow. Enhancement tests measured performance gain following optimization, confirming that efficiency improvements didn't affect stability. And I validated each enhancement respected by the original logic, maintaining the correct output results across all layers. While re-importing and testing, I encountered namespace dependency issues, and I made sure to note this within my defect log. Mainly caused by project restructuring and layer mergers. When the zip file was re-added to Visual Studio, it was recognized as a new project, so I had to manually relink dependencies, rebuild the solution, and ensure that references were in the correct place before testing could run. This process improved my confidence in debugging, dependency tracing, and understanding Visual Studio project relationships. Alongside code-based testing, I created sequence diagrams to validate system behavior visually. These diagrams represented the sequence of interactions within the edit config function to show how the jet interior configuration system processes and user configuration edits from the interface to the data layer. These diagrams represent how each layer interacted during key accidents, for example, saving, loading, validating configuration data, and by comparing my diagrams to the software design document, I confirmed that the logic, event order, and system responses aligned with design intentions. I maintain comprehensive QA documentation throughout the process, such as my QA plan, test plan, defect log, evidence mapping, and test results summary. Each artifact provided traceability between what was planned, executed, and verified. When my original module was taken over, I used it as a chance to innovate and strengthen the testing process. I expanded the QA framework to include system validation tests and validated this full end-to-end processes and refined regression cycles to capture potential issues earlier. This ensured that the quality was maintained and even through changes in team responsibilities. I chose MS Test as my testing framework because it integrates seamlessly with .NET, and it also provides a test attributes and allows for instant debugging within Visual Studio. I use test class and test method annotations to organize tests. And the Test Explorer gave a visual breakdown of the results within Visual Studio. The hybrid work for Visual Studio for execution and VS Code for documentation allowed me to maintain efficiency and compliance with network restrictions. This process really taught me how to maintain software quality under so many constraints, from switching between repository environments and manually managing repositories and moving zip files and not being able to open WF files due to company policies, but I really developed stronger skills in automated testing, debugging, regression tracking, and documentation management. And most importantly, I learned that effective quality assurance is not just about identifying issues, it's about ensuring quality through adaptability, even when tools and environments presents challenges. All the QA test suites passed successfully, with no errors, assertions, and warnings occurred across acceptance, integration, enhancement, and regression test. The JET configurator met its functional, performance, and reliability goals. Despite restrictions and changes in responsibility, I delivered a fully verified, evidence-backed QA framework that demonstrated both technical accuracy and professional adaptability. I overcame environmental restrictions, maintained professional quality standards, and validated every element of the JET interior configuration system. This work demonstrates my adaptability, resilience, and strong technical practice, which are key qualities in software and aerospace and beyond. Thank you so much for listening, and if you need any more information or evidence, they are located in the files folder of our Teams area.